Hello, everyone, and welcome to today's Energy Storage News webinar with TWAICE, where we'll be looking at the capabilities of advanced analytics in AI and the increasingly important role they can play in maximizing revenues for battery energy storage systems. I'm Andy Colthorpe, editor of Energy Storage News and deputy editor-in-chief of publishing here at Solar Media. In the past year or so, we've been able to dive deeper into topics around software and technologies that help the industry better understand their battery storage assets and how they interact with market opportunities. We often hear that storage systems, especially batteries, are a much more complex clean energy asset class than generation, due to their versatility in providing multiple applications, often simultaneously. Analytics are an important layer of that software piece, helping stakeholders from developers and investors to optimizers and even insurance companies and financiers successfully put their battery energy storage system, or BESS, assets into the right time and place to capture the revenue opportunities that those multiple applications present. You can, of course, watch our previous webinars on analytics with providers, including TWAICE, to learn more about the technologies from various angles. But today, we're excited to focus on state of charge imbalance and thermal analysis. So if we take examples of the US's two biggest and most important markets for battery storage assets today, CAISO in California and ERCOT in Texas, state of charge, or SoC, is a big talking point in both. Market operators see SoC as an important metric for assessing the reliability and availability of resources they can call upon. When bidding into CAISO's day-ahead ancillary services market, you have the option of forecasting your BESS asset's state of charge at the beginning of the next day. CAISO can then use this initial state of charge forecast to determine whether a battery unit can provide regulation up or regulation down frequency regulation services. And for regulation down, some larger assets will have a required SoC threshold. ERCOT, meanwhile, has been considering introducing minimum state of charge rules that could see stricter penalties applied if BESS resources fail to meet them. While efforts to introduce that set of rules between the end of 2023 and the start of this year did not go through, Energy Storage News has heard from developers and optimization experts that the topic is not going to go away. As I say, those are just two examples that scratch the surface, and today's expert speakers can tell us much, much more. Joining us are Ryan Franks, Senior Applications Engineer at TWAICE, and Dr. Philip Berg, TWAICE's Engineering Manager. And Ryan's presentation on the subject will be followed by a live demonstration of the TWAICE platform from Philip. As always, interaction with you, the audience, is really important to us, and we will end today's session with an audience Q&A. You can put your questions for the speakers in the questions tab that you can see on the right-hand side of your screen. We'll try to tackle as many as we can during the session, but rest assured, for questions we do not have time for, TWAICE will be happy to follow up and answer offline in more detail in the coming days. And finally, from me, this webinar is being recorded and will be available on demand at Energy Storage News, while slide presentations will be sent out via email to all people registered. So with that, and without further ado, it's my great pleasure to hand over to you, Ryan, our first speaker.
Thank you very much, Andy. So what we have here is, good morning, good afternoon, or good evening, no matter where you might be. We are very excited to present to you improving BESS performance and securing revenue. My name is Ryan Franks. As Andy said, I've been with TWAICE about 2.5 years, but I have been in the industry for about 17 years doing performance and safety testing, permitting support, and techno-economic analysis. Philip, could you introduce yourself briefly?
Yes, sure. Thanks very much, Ryan. I'm Philip Berg. My experience in the battery domain now lasts for 12 years. I started to first get in touch with lithium-ion batteries. And after my PhD 5 years ago, I joined TWAICE and currently leading our energy team as an engineering manager, and very happy to demo you today our newest development in our product. Back to you, Ryan.
Thank you very much. So you might be wondering, who is TWAICE and why are we talking to you? So TWAICE was founded in 2018. We've been around about 6 years, and we're proud to have grown significantly over that time. Really pioneered the field of battery analytics. At this point in time, we have over 140 employees. We have 3 different offices in Munich, Chicago, and Berlin, headquartered in Munich. In Munich, one differentiating factor is that we operate on-site testing labs for batteries and have a lot of hands-on research. But we're very proud to have received over $90 million in venture capital investment. And we're no stranger to wearing an academic hat and an innovation hat, continuing to publish papers and obtaining over 30 different patents. We operate across a variety of industries, including the automotive space, fleet mobility, like electric bus fleets, heavy-duty machinery fleets, and energy storage. Today, we'll be focusing on energy storage, but we work globally with organizations. You can see a couple here, like Fluence, M&8, Genies, Verbund, all over, but primarily, of course, with the market alignment in Europe and the United States in energy storage. We have all seen charts such as this. This shows the cumulative growth, the expected growth in energy storage deployments through 2030. You're seeing a 29% cumulative annual growth rate, and in 2030, you're looking at 2 to 3 terawatt hours. If you're on this call, you're expecting this. You're expecting to be part of this growth. But the data tells a different story as well. From a real system that we analyzed, in one day, one energy storage system generated 18 billion data points. If you go back to that chart and extrapolate that out to 2030, you're looking at all energy storage systems generating over 400 trillion data points in the year 2030. Therein lies the opportunity to use that data. So with TWAICE's in-life analytics platform, we offer a variety of modules dealing with the commissioning, health, performance, safety, and warranty. Today, we're going to be focusing on one of our newest developments, which is looking at the performance and availability of energy storage systems. So let's define the problem here. What you're seeing in front of you is a chart of availability of energy storage systems, individual assets in ERCOT, Texas, and Great Britain, simply because those 2 markets have the most transparency. And what you'll see is that in ERCOT, you're looking at a 97% fleet availability level. In Great Britain, you're looking at a little bit less, 95%. This is a chart from our friends at Moto Energy, where you're looking at the revenue per day. So 365 days in a year, and you can see at the right side of that graph, the vast majority of revenues are generated on just a subset of days out of the year. Similar story, very similar in Texas, but it's even more pronounced. 50% of the revenues come from just the top 13 days. And those are not stochastic. They're not evenly distributed throughout the year. There's busy time periods, as you all know, in at least in Texas, in the summer months, from June through September. Most of those high revenue days are taking place. So we've established here that there is a deficiency in availability. It's not perfect. And the days are concentrated in a certain number of months. So if you have a problem during those certain number of months, you run a greater risk of revenue loss. Oh, but now let's go to a poll here and take a bit of a break. Just 2 questions for you. The first here is, how many of your systems have been impacted by availability problems in the past 2 to 3 years? 0, 25, 50, 75, or all of them? And we'll just take a few moments here to allow you to answer that poll.
Thanks, Ryan. And so, yeah, if everyone could just click on the poll that you can see in front of you, we'll have a little bit of a think about what that kind of means. How about I put you on the spot, Ryan? What are you kind of expecting to see people say? What's your ballpark guess?
Yeah, I would expect 25 to 50% would have the most. You're seeing quite a few that have problems. I mean, it's typically an issue that is a little bit more pronounced as systems gain a little bit of age on them.
Okay, and can say that's a pretty good assessment from you there. So 38% of respondents said 25%. So that was the most common response. 50% was, so 18, so actually 50% and 100% were level on about 17% of the votes. And equally, I think it's really interesting to see. So you can see the results as well there, Ryan, right? So 100% of systems for some people responding were actually impacted by availability problems in the past 2 or 3 years. 16%, so just behind 50% and 0%. So a bit of a varied picture, but it obviously shows that it is a real issue there, I guess.
Perfect. And I suppose we could go to the next question here, alluding to how much has this actually cost in lost revenue?
Yep, thanks, Ryan. And the sums are, we'll just get that launched. Yeah, so the sums are $0 to $100,000, $100,000 to $500,000, $500,000 to $1 million, and more than $1 million. And yeah, how about another spot assessment from yourself, Ryan? What do you think?
Yeah, I mean, it depends upon the level of the fleet, but certainly, if you have over a couple hundred megawatt hours, I would not be surprised to look at the top two categories there: 500, $500,000 to over $1 million.
Great. Okay, and yeah, it's a really good engagement. So we've only been running this poll for a few seconds, but more than 100 votes from the audience, which is great to see. So 0 to 100,000 is 55% of respondents. Only 4% had experienced more than $1 million revenue impact, but still significant impacts of between 100,000 to $500,000 for 27%. So nearly a third of respondents actually experiencing between $100,000 and $500,000 impact, and 12% of respondents between $500,000 and $1 million. So pretty significant all round. I think folks have managed to avoid the most serious revenue haircut, let's say, of more than $1 million for the most part, except for an unfortunate 4 or 5%. But nonetheless, yeah, pretty significant numbers, I guess we could say.
Yeah, I mean, that's astounding. I mean, if you look at the integration of that, think about the global amount of lost revenue from availability problems. And, that's just confirmed. This is a quote from a customer of ours last year. Availability is critical for us. We are seeing revenues underperforming, and the first thing we want to do is check availability. That's from a senior director of asset management. Everybody has this problem. Availability is, if you could just increase that 1%, though, availability is generally worth about $2,000 per megawatt of power per year. So you don't necessarily have to solve all of the issues and make it a perfect system, but just investing in cutting out some of those availability issues lead to a tremendous ROI. So we've established here the problem. Availability issues directly lead to revenue losses. There's a couple other issues that go along with that, though, looking at maintenance. How do I identify which areas of the energy storage systems, which area of the DC block is having trouble? How do I pinpoint the root cause of what is actually going on in the system? And how do I look at maintaining the lifetime of the system by ensuring optimal performance? Enter the solution, however. So TWAICE has rolled out a performance manager in June. What we're going to do here is show a demo by Philip here, but the real system that this is on was a 470 megawatt hour energy storage system. It was LFP. It was expecting to make about $10 million in revenue per year, but it was missing that by 10%, $1 million. So this issue was on everyone's mind, from the CEO on down and all stakeholders in the value chain. And the delta here is that you might often notice that there's a problem. You're not meeting your inverter set points, or there's some issue with not being able to meet the capacity or the power that you need for a charge or discharge. The delta here is being able to go several layers deeper, several layers more granular, to identify which specific areas of the DC block are causing that. Philip, I'll turn it over to you.
Thank you very much, Ryan. Yeah, today we will concentrate on the SoC imbalances in the system and their effects. The Performance Manager also covers other aspects, like, for example, temperature issues you can face. But today we will focus, given the limited time. What are the challenges? There is varying cell quality in the field, especially with the large ramp up. There are more and more factories. The business has to move pretty fast, so not every cell is the same. This causes then often that the BMS is not able to also balance properly. And as we will also see later, imbalances can have effects on the BMS SoC to degrade, which then can cause issues down the road, like Andy presented at the very beginning very clearly how important an accurate SoC is to go into the market. So there are several impacts. So imbalances can cause inverters to trip. We have seen systems which actually went into overcharge and over discharge of single cells, which can become a safety critical issue, or at least significantly stresses the cells. And we also will have a look at the sibling effect, where different strings in one node will negatively affect each other. So the Performance Manager helps to pinpoint these imbalances immediately and to carry out further analysis and act accordingly. So now, without further ado, let me share my screen and let you give you a short demo of our Energy Analytics Suite. So this is the screen you are entering, your landing page, where you directly get your complete asset portfolio with all your storages. You see the performance status, you see the safety index and the state of health spread as entry points to different solutions. So looking at your state of health to plan augmentation, for example, looking into the safety index to identify all critical issues happening in your system, to take early action and to avoid that something critical happens. And today we look into the performance status for the Cactus storage, where you see that here, actually on the daily impact, if you assume you want to run one full cycle for your system each day, this system, due to its imbalances, where we here see 98% of nodes have issues, actually 100 megawatt hour cannot actively participate in the market, resulting in a daily US dollar loss of around 12K USD, with an assumed average revenue per megawatt hour here. 98% sounds pretty dramatic, but actually it's something we regularly see in the field, especially when it comes to LFP. So let's look into the solution. This is the landing page, then the dashboard of our Performance Manager solution, where you directly get a to-do list and a list of nodes and strings which need your action.
Hi,
this is sorted by the... Yes?
Sorry to interrupt. Do you think you could zoom in a tiny bit? I think a couple of the audience felt some of the lettering was a little bit small. Sorry about that.
Is that better?
Yeah, perfect. Brilliant. Thank you very much.
Okay. And yeah, here you can directly identify which node needs my most attention. And for this example, we will look into this node 5.6. And we can then further dive into the solution, where you see here the progression over time, how your different nodes behave, and if the state of your system gets worse or better. On the right side, you always keep the overview, the to-do list of your nodes. So you find again the string 5.6.6 of inverter / node 5.6 with this high SoC spread. And down here, you can also directly compare the nodes and can also take a deeper look. So here you see again node 5.6, and you can also see that actually one specific string is much more worse than all the others. So this string really sticks out with this red square, and you immediately want to fix that one string. How you can do that is you can dive again a level deeper, and you can also see the progression over time for this string. And you see this actually happens already since quite a while and could not be fixed anymore. Let's look into some negative effects, which I already covered a bit. So here you see the daily cycles for this node, and you see that this string 5.6.6 can contribute much less compared to the other strings. But the actual bad part is if you compare to other nodes which get the same power demand request, that all strings in this node can contribute less. So this one string actually limits the whole unit and therefore limits your overall output. So it might be better to take this string completely out until you have been able to fix it. Also, as we talked about the BMS SoC issues, as you can see here, this is the BMS SoC we get from the system, which says that you are only using the battery from 100 to 75% SoC. But if you look at the cell voltages, you actually see that we go below 3 volts, so we are actually pretty much discharged, which also gets reflected in the different TWAICE cell SoCs, which we calculate, where you see the maximum cell and the minimum cell being pretty far apart. So here we can see that especially when it comes to large imbalances and when single cells or modules drifted away for some reason, then the BMS SoC usually really gets in trouble for LFP because of the flat OCV of all the cells. And this is where then several downstream effects can happen. Let's also look at one more positive example. So here, for example, inverter 20.6, you see in a lower list, which is your early warning list. This only has a spread right now of 19.8%. Let's have another look here. And we find that inverter 20.6 is this one. And we look over time again. And you see that here in January, there was a maintenance action taken. There actually parts of the strings could be fixed, not all of them, but you see that many of them return to green. So you see that the earlier you take action, the better chances you have that your maintenance activities are successful. And there are also, if you look here, for example, at a very positive example, you can actually see that if you take early action, that you can basically bring your whole system back into a good state. So with imbalances, you really want to know at the forefront and you want to take early actions before things become more difficult to fix. This is the demo today. If you are interested in more details, yeah, happy to give you another demo. Let me switch back to screens and back to Ryan.
Thank you very much, Philip. So, as we saw in this system, this is a kind of a game changer for being able to go from a system level, I have an availability problem, I'm not meeting revenue, to how do I actually begin to fix this issue? In this particular case that we worked on, it was found that just 6 modules were contributing the vast amount of imbalance that was present in the system. And this is a really good example of battery analytics. There's this confusion sometimes around how does battery analytics relate to EMS and BMS. BMS is a simple system, a programmable logic circuit that controls the basic safety functionality of the battery and the basic operations, the measurement, the balancing, battery state control, safety. EMS on top of that, depending upon how you define it, ties together the battery with the rest of the system, and in some forms does trading, depending upon how you define it. Analytics sits on top of that, doing advanced computation, looking at much longer time frames, looking at trend and root cause analysis, forecasting, and proactive alerting. And just a reminder here that this is one element of in-life analytics. So this we've highlighted today is the performance element of the software stack. There's also elements that relate to the health, safety, warranty, performance, and lifetime, all revolving around taking that data from an energy storage system, bubbling it up, applying data science principles, and producing KPIs, some of which are proprietary. And with that, we'll turn it over to Q&A.
Fantastic. Thank you so much, Ryan, and thank you, Philip. I think it's it's really cool how you're able to demonstrate in such a let's say readily visualizable kind of way, a lot of the issues within, and that in itself has generated plenty of questions from the audience. So we'll try and get through a few in the minutes that we have left. So yeah, a question from Johnny in the audience. So thanks for your question, Johnny, asking about whether the SoC spread, so the state of charge spread is based on state of charge reported via the BMS, the battery management system, or is it an internally calculated state of charge?
I can take that question. It's an internal calculated KPI. We always deliver 3 SoCs, 2 on a cell level, the max and min which you have seen, plus the effective string SoC you get. But for all our solutions, we only trust our own SoC calculations, as you have seen that many BMS SoC calculations can have issues and also are differing quite much between different integrators. So we want to use our own standard.
Okay, and I think on a somewhat related note, I guess, not just about where the data comes from, but how it's relayed into the analytics. So Antti, thank you for your question. Antti was asking, what type of an API do you require from the BESS, or is the BESS expected to push the data to your API?
You want to take that?
Yeah, so that's an excellent question. So we have 3 methods of incorporating data into our platform. We run an AWS. We can either use a push API, a pull API, or a periodic transfer of time series values in CSV form to a secure FTP server. So we're very flexible on how we can actually get the data from the system to our platform. In many cases, there's often a data historian or data lake functionality in between the actual energy storage system and our analytics.
Okay, terrific. And sorry, yeah, there's still loads of questions coming in. So do rest assured, all of you that will ask fantastic questions, you will get these replied, perhaps not today, probably not today, being honest, but you will get those replied in time via TWAICE, who'd be more than happy to follow up. But let's get through a couple more if we can, and I'm sure we've all got time for that. So let's try and kill 2 birds with 1 stone. So Carla asked, what parameters are used to calculate the safety index? And on a somewhat related note, Kilan asked, what is the threshold for flagging safety index and balance? So Kilan's question was about, what kind of threshold triggers those safety index and balance and imbalance, warnings or indications, let's say, rather than warnings. And Carla asked what parameters are used to calculate that safety index.
Yes, I can take that question. Our TWAICE platform has, in another area in our safety monitoring, we have an incident detection engine, and this engine can detect anomalies, threshold violations, and different ways how things can go wrong, and we can go apply this to every KPI. So we apply these to the sensors which we directly get, like current, voltage, basic overcharge, over discharge, temperature, but we can also apply these to our SoC spreads, to the error in BMS SoC and many other. So it's very flexible. And depending on the duration, the time when it was, so how much it lies in the past, plus the severity, we calculate the safety index out of the sum of all these incidents which we detected for your specific storage. And then internally, we calculate a safety index, and this then gives it a weight to be critical, medium, or normal. I cannot give you the exact percentage number now when this is going to happen, but this is a trained algorithm which we have developed to give you the priority and the risk assessment of your several incidents which happened.
Okay, terrific. And there's a question here that's a little bit more general, I think, and it's sometimes nice to zoom out to the bigger picture, I guess. And so Henrique, thank you very much for your question there. I hope I've got your name right as well. But Henrique is asking, what is the role of AI within battery analytics?
Yeah, maybe I'll start on that, and Philip, you can add on. So yes, so primarily in calculating state of charge and state of health, we employ machine learning techniques that incorporate how lithium-ion batteries degrade, and through the combination of their electrical, thermal, and calendric aging properties. So it is not simply a regurgitation of the BMS data, but rather a more accurate way to calculate SoC and SOH. Philip, anything to add?
No, I mean, you mostly covered it. In general, I mean, in battery analytics, it's very important to always keep the physics in mind. So applying a deep learning algorithm or something wouldn't work. So you always need to keep the physics. You need to understand the specific battery. That's also why we have a lab attached to also do our own measurements. So it's very important. And then AI can play an interesting and helpful role to achieve certain steps along the way.
Okay, terrific. And I guess maybe the last question for today. So Hakeem asks, and thanks for your question, Hakeem. So you did mention that the SoC, that you calculate the SoC yourselves rather than taking the BMS data reported, from what the OEM provides, which Hakeem says they would have expected to say. But if that's the case, can I ask how you achieve this? And you did slightly allude to this in your earlier question, but maybe it'd be nice to finish on a bit more of an explanation of that.
Yes. So at the end, the input signals which we need to provide this is temperature, voltage of the minimum cell, voltage of the maximum cell, string voltage, and current. And these are the signals which you need to provide us. The higher the resolution, the better this gets. And we developed our own algorithm there. Won't reveal all our IP now, but I can say that modeling the battery in a very good way, understanding the OCV behavior, understanding aging effects, understanding hysteresis effects is very important.
Great. Okay. And I think just time for one more quick question. So from Clint, thank you very much for your question. And Clint says, if I understand correctly, your product provides information about the condition of the battery, and then it is up to the system operator to take action to correct issues that you identify. Is that correct? And yeah, how does that, I mean, just that process of relaying information, I guess, if you want to maybe add a bit of color onto that, that would be nice, I think.
Yeah, I'll take that one. So yeah, that excellent question. So yes, I mean, Philip, our team, we are not the people driving around with modules in the back of our trunk. Our job here is to be able to pinpoint the issue. And that's exactly correct. And I will just add as one more sentence is that, sure, sometimes you might have if you're an asset developer, a project owner, there might be skepticism from the integrator, from the EPC, from the other players in the stakeholder chain. But what we've seen time and time again is that initial skepticism is really overcome very quickly because these entities are facing liquidated damages from not being able to fix the problem. And once we're able to identify the simple fixes that'll drastically improve availability, everybody's on the same page towards creating reliable, high-performing, cost-efficient energy storage systems.
Yeah, so ultimately, I guess it's about kind of partnering up within that project ecosystem or that portfolio level, or essentially not so much a layer of mistrust with, say the OEMs or whatever, but actually building up layers of trust, I guess, all around between all of the stakeholders, I guess, unless I'm much mistaken. Cool. Okay. Well, everybody, it's been a really illuminating session, I think, and so much so that we do still have some questions coming in. So really great to see. And as I say, rest assured, you will get your questions answered and have the opportunity to go into a deeper conversation with TWAICE. You can see Ryan and Philip's email addresses are on the screen as well. Should you want to connect with them directly, you can also go to www.twaice.com. And so, yeah, with that, I guess all that remains is for me to say thanks so much to you, Ryan. And to you, Philip. Thanks a lot for joining us. And most of all, thank you so much to our audience. It's been great. And so many of you have joined in. And yeah, it's been really, really interesting. We look forward to learning more about this subject in the near future. And yeah, please do all keep up your hard work in this incredible industry. I think that's the key takeaway from me, I think.
Thanks so much, Andy. Thanks, everyone.